What's up, Jeaner? Let's do number 5, and this one is a little bit more my type of thing, so should go a little bit smoother than that last question. So, what's going on now is that we have a question that's asking for the total moles of ions that are released when the following sample dissolves completely in water. So, the sample that they're talking about is 6.188 times 10 to the 21 formula units. So this is dumb. Formula units of NiCl2. So there's two main things that you should know when approaching this question. Both of them are pretty dumb. The first one being that formula units is the same thing as molecules. And whenever you hear molecules, you should be thinking of Avogadro's number. I don't know how to spell his name. Avogadro's number. And so 6, what should come to mind is 6. Why isn't my pen working? 6.022 times 10 to the 23 molecules per mole. So this should be your thought process. This part, not so much because that's dumb, but this part, yes. When you think molecules, you should be thinking Avogadro's. And now whenever you're thinking Avogadro's, you should be thinking of his number, which is 6.022 times 10 to the 23. Okay, so the second thing you have to know is the breakdown of the ions. And so basically when you go into the periodic table, what's up with this surface lately? Ugh. Ugh. Why aren't you writing? Okay. Technical difficulties. So basically, when you look in the periodic table, your nickel gets a +2 charge, and your chloride gets a +1 charge. And so now we could answer the question. So because we have 6, because what they're asking for is our moles, first thing we got to do is convert our formula units or molecules into moles, and luckily we have Avogadro's number, which does just that. So we have 6.188 times 10 to the 21. I'm going to say molecules, but molecules and formula units are interchangeable. 6.022 times 10 to the 23 molecules per mole. And so molecules and molecules cancel out. And what we're left with is moles. So we have, 0.01027 moles of NiCl2. And keep in mind that what they're asking for is how many total moles of ions. They're not asking about how many total moles of NiCl2, because whenever you mix it with water, it's not going to be just NiCl2. What's going to happen is the Ni is going to split, is going to go in one direction, and it's going to make separate ions from the Cl, and that's going to split, and of course there's 2 of those. And so it's a little bit more complicated than just asking for the moles of NiCl2. So the way we find that is back up here with this part. So basically what happens is I'm going to write the dissociation, which means what happens when I mix it with water and this thing splits. I get 1 Ni, and of course Ni is plus 2. And I get 2 Cl's all floating around in there, and Cl is plus 1. And so because now this is what's floating around, and I have this many moles of Ni and Cl, I have to now multiply that amount of moles by the amount of ions that I have floating around once they split up. So what that means is I have this times 0.0127, and I have this times 0.0127, and so what I have is 0.0127 of nickel ions floating around, but I also have my chloride ions floating around, so 2 times 0.01027 is 0.02054, and so the total amount of ions that I have floating around, which means nickel ions and chlorine ions, is just the addition of those. So I have 0.03081, and so if you put that into scientific notation, that's 3.081 times 10 to the negative 2, and that's answer choice E. Okay, cool.